All right, so we're given a quadrilateral here. It says given J is the midpoint of KM and NL. So it's the midpoint, J is the midpoint of both diagonals, okay? And we're trying to prove that side KL is parallel to side NM. All right, so follow along as this guy kind of explains how he would go about proving it.
Looking at one like number 3, 3 is a little different. It tells you that J right here is the midpoint of KM. So we automatically know that those are going to be the same because the definition of midpoint. If it's the midpoint of NL, we also know those are going to be the same. They don't want me to prove anything about two triangles here though. But I may have to use that because what they want me to prove is actually that this KL is the same as NM. Well, how do I do that? In order to do that, I need something about angles because I remember that in order to prove things are parallel, I'm going to have to do a converse here. So it's going to have to be something about an angle. What would be nice is if these two triangles, this one right here, JKL, was the same as MJN, these two. We're close to it. We got two sides. I just need an angle or a side. I'm going to jump to an angle here and say, well, aren't these two automatically congruent? Because these two are vertical angles. And we can prove that they're congruent, in which case I'm going to get side, angle, side. So in other words, you're going to get here the triangle JKL is going to be congruent to MJN. Why? You're going to get because of side, angle, side. That's going to be your reason. But once these are congruent, then and only then, I know every part of these two triangles are going to be the same, including the side, including these angles. Well, wait a minute, the angles are really nice because then I know these two are going to be the same. I'm going to call that LKM. Okay, or you can call it MKL, either one. And the other one I can call KMN or NMK. But I know that these two angles will be the same. Why is that useful? Because then I have alternate interior. And if the alternate interior angles are the same, then these lines have to be parallel. And that's kind of my thought process as I walk through this proof.
All right, so let's see how this looks in proof form. Okay. We've got our given information, which is J is the midpoint of the two diagonals. We talked about how you could get two pairs of congruent line segments from that midpoint of J. That doesn't mean all four of them are congruent. It's drawn to look like a square. If it was actually a square, then all four of them would be not only congruent to the pair that's on the same diagonal, but even both diagonals. But we don't know that. In fact, we don't have enough information to say it is a square. So all we can say is we have these two pairs of congruent line segments. The next step, they use two steps to talk about vertical angles here being congruent. I'm perfectly fine if you guys put this into one step because vertical angles are always congruent. So you could have gone straight to angle KJL is congruent to angle MJN based on the fact that vertical angles are congruent. But they use two steps. They basically identified them as vertical angles and then said they're congruent. One step would have worked. We have enough information then to prove the two triangles are congruent by side, angle, side. Once we know the triangles are congruent, we can talk about those two segments. Sorry, those two angles being congruent. Angle LKJ and angle NMJ are congruent by CPCTC. Once we know those angles are congruent, we know that we can identify them as alternate interior angles. All right. They're alternate interior angles. And once we've proven that alternate interior angles are congruent, that is enough information to say that the two lines are parallel. KL is parallel to MN because there are congruent alternate interior angles. Right? You can't just jump straight from CPCTC to the last one, all right? because we have to say that they are alternate interior angles, right? We have to at least say they're alternate interior angles. Once we know that they are, and we've already proven they are congruent, that proves that the lines that they are made up of, that those two lines will be parallel with that transversal, the diagonal in between them. Okay, so there's one example. Here's another one. It says, given LM bisects angle JLK. So the segment LM, the one in the middle there, is bisecting the big angle JLK, and JL is congruent to KL. All right, no video on this one. It's all us. So I'm going to mark down what we have here so far, and we're given that LM bisects angle JKL. So I know that because it's bisecting it, it's going to cut this angle into two smaller but congruent angles, right? We're also given that side JL is congruent to side KL. And one other thing I see in here is that we have a shared side between these two triangles. Now, I guess we need to figure out, do we need, because we're not trying to prove the triangles are congruent, we're trying to prove that M is the midpoint of JK. Well, in order to prove that M is the midpoint, I need to know that JM and KM are the same lengths, that these two sides are congruent. All right, I would need to prove that. Now we can't assume that, and we don't know it to be true yet, so we can't say that yet. But we can say that the shared side is going to be congruent to itself. And once we know, if we have enough information to prove that these two triangles, triangle 1 and triangle 2, are congruent, then we can go back and we can say, oh yeah, because of CPCTC, these are congruent. All right. So that's what we need to do. We need to prove the two triangles are congruent. Then we can prove the segments are congruent. And once the segments are congruent, we know that M is the midpoint, because if it's the midpoint, then we have two congruent segments. All right. Let's take a look at our proof. All right, so we have our given information of LM, segment LM bisecting angle JLK. Because of that, we can talk about those two smaller angles being congruent. Angle JLM is congruent to angle KLM. That is the definition of bisector. The other given information we had was the side JL is congruent to side KL, given. And to get our last bit of information so we can prove the triangles are congruent, we need to identify the shared side that is congruent to itself. Side LM is congruent to side LM, and that is because of the reflexive property. Right? That's enough information to use side angle side to prove triangle JML is congruent to triangle KML. Once those are congruent, we can then talk about those bottom segments of both triangles being congruent to each other because they correspond to each other. And that is because of CPCTC. And lastly, once we know that those segments are congruent, we know that M is the midpoint of JK because of the definition of midpoint. Okay. All right, now the next problem uses the exact same diagram, but we're given different facts. So you gotta kind of treat it as a different problem. All right. Given LM is perpendicular to JK and JL is congruent to KL, prove that M is the midpoint of side JK. All right, so we're still trying to prove that M is the midpoint. So we still want to get to a point where we know that JM and KM are congruent. But in order to do that, we probably still need to look at proving triangle 1 is congruent to triangle 2. Because we don't have enough information, even from all this up here, to say that these segments are congruent yet, or that they're the same length. So let's mark what we know here. We got these sides again. Now, instead of knowing anything about these angles, we're given information about these down here. Segment LM is congruent to segment JK. Sorry, not congruent, is perpendicular. Means that we have these right angles, okay? We have these right angles here. Now, Mark my last part here. We have a shared side again. It doesn't look like I can't use angle, angle, side, or angle, side, angle, or side, angle, side, or side, 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 or yeah, that's the last one I'm about to say. I think we can do. I think we're going to use hypotenuse leg. This is a right triangle. Both these are right triangles. Okay. And the angle is not in between. We only have one angle. So we have to use something else. We got to use hypotenuse leg. These two, LJ and LK, or these are the hypotenuse, and the shared side will be the leg. So we do have congruent hypotenuse and legs. And they are right triangles. So those are the three facts that we need to show here. Okay. Once we know those are through hypotenuse leg, we have congruent triangles. We can go back and prove that these segments are congruent, which then proves M is the midpoint. Okay. Check out the proof. So we got our given information about our perpendicular segments. Once we have our perpendicular segments, we know that they form right angles, right? We have to identify that. We have to identify that the perpendicular lines form right angles, and we have to identify the two right angles. Once we've identified the right angles, we can say that the two triangles are right triangles, because that is one of the facts we need to use when we use hypotenuse leg. So I say triangle JML and triangle KML are right triangles. And we can say that because all right angles are, that shouldn't say congruent. It should say triangles include right angles. Sorry, I meant to change that to say it a little bit. But we need to we can say that they're right triangles because both triangles include a right angle. Once we know they're both right triangles, we need a couple other facts. We need to talk about the hypotenuse being congruent, which is the second given fact. Segment JL is congruent to segment KL, given. And we need a leg congruent between the two, and that's the shared side. Side LM is congruent to side LM based on the reflexive property. Since we have the fact that they're right triangles, we have the fact that we have the hypotenuse and we have a leg. That's enough to say through hypotenuse leg that triangle JML is congruent to triangle KML. From there, the proof looks exactly the same as the previous proof, because now we can say that JM is congruent to MK. Those two segments are congruent based on CPCTC, making M the midpoint of JK because of the definition of midpoint.